In the first part of this lecture on the hormonal regulation of ovarian and uterine cycles, we got up to the point where there was a surge in luteinizing hormone release. And that happens because there's a dominant follicle that secretes a lot of estrogen, and the estrogen provides positive feedback to the anterior pituitary, and the anterior pituitary in response releases a lot of LH. And that helps a number of things. I mentioned that it causes the oocyte to complete meiosis 1 and start meiosis 2. It facilitates ovulation of the oocyte as well as the polar body that's attached to it. And it also causes the follicle that's been ruptured to transform into the corpus luteum. And it's the corpus luteum that will make progesterone. So we talked about the fact that this high progesterone made by the corpus luteum, right here is the high progesterone number 12, actually exerts a negative feedback to the anterior pituitary gland, causing a drop in both LH and FSH. So no longer will you have FSH acting on the ovary or luteinizing hormone acting on the ovary. And with no luteinizing hormone, this corpus luteum will eventually degenerate. And it degenerates into a structure called the corpus albicans, which is kind of a connective tissue, scar tissue-like region in the ovary, the corpus albicans. It doesn't make any hormones. So in response, we don't have the corpus luteum making progesterone, and we're not developing follicles that make estrogen. So in response, what you see is a drop in both estrogen and progesterone levels. Without estrogen or progesterone production, then negative feedback inhibition is released, it's removed. And so now the luteinizing hormone and follicle stimulating hormone will be made again by the anterior pituitary. And so you'll see them slowly begin to rise. And the ovarian cycle will repeat. So to summarize what happened after ovulation, the follicle is no longer making estrogen. The corpus luteum makes progesterone mainly, but also some estrogen and inhibin. And that inhibits both of those, the high level of progesterone as well as this molecule inhibin, inhibits both the pituitary and the hypothalamus. That causes a decline in luteinizing hormone and follicle stimulating hormone, which means that you won't have follicles developing and you won't have estrogen production, and the corpus luteum is going to degenerate as well. And so eventually progesterone levels will decline. And when that happens, now the hypothalamus and the pituitary gland are no longer inhibited. And eventually you'll see a rise in LH and FSH levels. So that was a lot of information on the ovarian cycle in a stepwise fashion. Using that worksheet, I hope it helped a little bit. I want to show you kind of a shorter version, a 12 or 13 step version versus a 16 or 17 step version, and just see if this clicks for you. So again, we're connecting the pituitary hormones with just the ovarian cycle. And first, what we see each month is a slow rise in both luteinizing hormone and follicle stimulating hormone. The follicle stimulating hormone promotes the growth of the follicles. the follicles and the cells in the follicles produce estrogen. So we see a rise in estrogen levels. The dominant follicle is selected without talking about why or how. And this dominant follicle produces, oh, I've circled the wrong thing. Dominant follicle, number 4, produces a high level of estrogen. And that estrogen causes a peak in FSH as well as the LH surge. The LH surge promotes ovulation, and once ovulation occurs, the follicle is ruptured and it gets turned into the corpus luteum. The corpus luteum makes progesterone, high levels of progesterone, and progesterone inhibits the anterior pituitary, and so we see a decline in both FSH and LH. Now with that decline comes the demise of the corpus luteum, and so the corpus luteum is going to degenerate, and it degenerates into a structure that's kind of a scar-like structure called the corpus albicans. And the corpus albicans does not produce progesterone, so you see a drop in progesterone, and we've already had a drop in estrogen. But these drops in both estrogen and progesterone remove or eliminate the negative feedback on the pituitary, and so now we can start all over again with luteinizing hormone and follicle stimulating hormone slowly increasing, and you begin a new ovarian cycle. So that's it for the ovarian cycle. Now we need to think about how does the ovary and these ovarian hormones, estrogen and progesterone, simultaneously affect the uterus. So to do that, let's recall the phases of the uterine cycle, or we sometimes just call it the menstrual cycle, assuming that pregnancy doesn't happen. So there's 3 phases of the uterine cycle: the proliferative phase, the secretory phase, and the menstrual phase. Now you need to remember the layers of the endometrium for those phases to make sense. So we have one layer that's deepest in the endometrium called the stratum basalis. And the stratum functionalis is the more superficial, well, I guess it's deeper in a way, but it's closer to the lumen, the stratum functionalis. So in the proliferative phase, what we see is mitosis, really in both layers, but in the stratum functionalis in particular. So you get formation of the stratum functionalis. This happens in response to estrogen and occurs when the ovarian follicles are making estrogen. Then ovulation happens, and now we have the endometrium entering the secretory phase. And the secretory phase involves the vasodilation of these spiral arteries, giving the endometrium rich blood supply. Why do they dilate? They dilate because progesterone is secreted by the corpus luteum, which forms after ovulation has happened. So ovulation occurs, the follicle dies in the ovary. It doesn't exactly die. It gets transformed into the corpus luteum, which makes progesterone, causing the secretory phase in the uterus. Now, if pregnancy happens, I should say if fertilization happens, and then implantation of a fertilized oocyte or a zygote occurs, things stay pretty much status quo. The uterus stays in the secretory phase. But If there's no fertilization, then the corpus luteum degenerates.